There's nothing more important for life than clean water. We've known this forever, yet we still struggle with water pollution. In the state of North Dakota, 93% of our streams are impaired by nutrient-rich runoff that causes toxic algae blooms. There's a solution for this: wetlands. Wetlands slow water down, allowing particles to drop. Nutrients are captured by wetland plants and microbes, so water leaves a wetland cleaner than it entered. On top of this, wetlands are among the most productive ecosystems on Earth, meaning they efficiently capture the CO2 that impacts our climate. None of this is news. For decades, we've constructed wetlands in order to improve our water quality. But there's a question that remains. What is the area of land that would need to be converted to wetland in order to solve specific water quality issues? The first part of my dissertation aims to answer this question through computer modeling. We selected 3 polluted streams within the Red River Valley and evaluated the impact of various wetland construction scenarios. Basically, we find the source of pollutants, add wetlands appropriately sized to capture them, and we keep doing this until water quality goals are met. Though this work is still ongoing, early results suggest that goals can be met with roughly 2% conversion of land to wetlands. Which brings me to the second part of my dissertation. How can we make this scenario more economically feasible, and how can we manage wetlands to make them as efficient as possible? I believe the answer to this is in harvesting the highly productive plants, such as cattails, that dominate nutrient-rich wetlands. Through harvest, we can remove the nutrients and carbon that plants have absorbed before they inevitably release them through decay. Cattail harvest isn't a new idea, but it rarely occurs simply because we don't have a valuable use for them. This part of my work aims to develop such a use: potting media. You can see the basic strategy in this slide. Society releases carbon dioxide and nutrient runoff, which currently follows the yellow arrow into lakes. With the strategic addition of wetlands, that runoff can instead be captured by cattails, processed into potting media, and returned to society. Cattail potting media would not only help to solve our water quality issues, but could help to discourage the mining of peat moss, a practice responsible for 5% of Earth's annual CO2 emissions. So far, I've developed and tested 4 cattail products for suitability in horticulture and found that cattail compost and cattail biochar show potential. We're currently working to improve these products, and future work will determine their economic value. So, to wrap it up, my dissertation aims to determine the area of wetlands needed to solve our water quality issues and to develop a product that increases the feasibility and sustainability of that wetland-based approach. Thank you.